Okay, welcome back. We're talking about inheritance and how this is not an example of multiple inheritance. There's an interesting story. In the early days of OOP, C++ was the primary language that kind of introduced OOP to the world. And at the time, they had this thing called multiple inheritance where you could inherit from a button and a text box simultaneously. So you'd get all the stuff from the button and all the stuff from the text box, and you could inherit from both of them. When it came time for a lot of the modern languages to look at it, for example, Microsoft went through and looked at all of the source code they have for every product they've ever produced, and found out that in everything they've got, they only use multiple inheritance like 2 or 3 times for everything they've ever done. And they went, well, we ain't gonna do that. And so modern languages, typically like Java and C# and a few of the others, don't really support multiple inheritance because, quite frankly, it's a good intellectual exercise, makes great textbooks, but in practicality, no one uses it, so let's just move on. Okay? All right. On page 243, they talk about polymorphism. So polymorphism means if I have an employee class, and then an employee exempt class, and an employee com plus, and in there happens to be something that says calculate pay. It's the same calculate pay. I mean, the name of the method is calculate pay, and the method name stays the same in each one of these cases, except the pay is calculated differently. In this one, in the top one, they get overtime. In the middle one, they don't get overtime. And in the bottom one, it's only based on commission. It has nothing to do with how many hours they worked. So their pay is completely different depending on what type of employee there is. So polymorphism means I could put those guys in an array or an array list and have an array list of employee instances. And when I ask it to calculate the pay, it's going to say, hang on a second. Before I calculate the pay, let me see if there's a better version of calculate pay. Oh, yeah, there's a specialized version, so it's going to do that. All right, that's what polymorphism is all about, which means if I was to have an array list of these things and say calculate pay, and then I add another type of employee, I wouldn't even have to go back to that piece of code and make any changes whatsoever. Remember we talked about side effects? I can add another employee class without altering my payroll app. Wow, isn't that pretty cool? All right. So, whenever a method is being called, the machine says, hang on, let me go check to see if this is a good method or should I call a better one. Okay. So a non-technical example would be a board game where you'd have a board game where you have an animal and you want the animal to move from one square on the board to another square on the board. And so if it's a bird, you want him to fly from one square. If it's a snake, you want him to crawl. If it's a bunny, you want him to hop. And if it's a dog, you want him to walk. If it's a fish, you want him to swim, right? How you get there. But I can just say, okay, animal, I want you to move. And the machine's going to say, well, you told me to move, but if I'm a bird, I'm going to do this. And if I'm a fish, I'm going to do that. If it's a snake, I'm going to do that. In other words, you tell it to move in the general sense. In other words, you program to the general, and it will figure out how to mechanically make that happen. That's what polymorphism is all about. We are going to demo this coming up, so just hang in there. So on page 244, it's one of those good philosophical questions of, why are we doing this? And this is a very, very good question and a source of lots of questions on quizzes. So I like to include things like this on quizzes. So why are we doing this? Well, using all these techniques we just talked about, polymorphism and inheritance and, encapsulation and all the rest of that stuff. It makes programs easier to write, so that means it's less work for me, the programmer. It runs fast. It takes less time, right? Because I don't have quite so much to do. And then one of the cool things that happens is in a corporate environment, you're probably not working alone. And remember we talked about side effects, okay? I could take a big task and break it up into 12 chunks because I have 12 programmers. Each programmer can get one chunk, and if I do it correctly, where there's no side effects, the chunk that I gave to Sally to do isn't going to have any effects on the one I gave John to do, so they can work completely independently. They don't have to get together periodically and say, hey, I'm planning on calling this variable kumquat. What are you guys going to call it? You don't have to do any of that because they're intended to work on their own little pieces and then they get combined together. Okay, so in a corporate environment, programming houses love OOP because they can speed up the process by hiring more programmers and breaking them up into chunks. Now, I'll confess, in your world, when you're just a student or you're working by yourself, you're thinking, well, that doesn't provide me a benefit at all because I'm not working as a team. Okay, granted, but there's still lots of good information here. Okay, so on page 244, let's just kind of do a recap of all this stuff. So a class. A class is typically a person, place, or thing, a noun, a student, an employee, I don't know, a schedule for the university or something, okay? Or a professor at the university. Those are all nouns, or kind of, sort of. So they contain both data and action, so nouns and verbs. That kind of, sort of makes sense. A class is a blueprint, right? A blueprint. And so data is stored in what's called fields. And then there's a technique that you have to gain access to those fields. Now, I'm going to do one here. And I'm not going to spend too much time actually explaining what I'm doing, okay? Because that's coming up in another chapter. So I'm going to do it, and then we'll talk about it. All right. So what I want to do is I'm going to add me an employee class. So I'm going to go here and say new class employee. By the way, as far as naming convention, classes are Pascal case, which means they start with an uppercase letter. Okay, cool. All right, so not to bore you guys with too much, I'm going to copy and paste this because that's not really what we're doing. Okay, I've copied and pasted this from a paste buffer. Okay, by the way, when you're copying and pasting from other code, either don't get this package, or if you accidentally copy the package, you'll have to fix it. Because the package is one of the things that is unique to that particular project that you're working on. So I created an employee class, and once again, I'm not going to get into the details of it because that's not what this was about. All right, so I'm going to go here and I'm going to create me an instance of an employee. So the simplest way to do that is to say, so employee is the name of a class, but the class is also a data type, just like integer and string, right? Okay, so, and I'm going to call mine emp1 is equal to new employee. Okay, so I've just created a brand new employee. Now let's stare at this for a minute and look at it. All right, the word employee shows up twice in line 20, and it's kind of important that you understand what's going on. The first one, this one, is when it's being used as a type, okay? Because edit text is a type, okay? So employee is a type. And so it shows up as a type, and then it shows up a second time, and this is a special thing. This is a method. Ooh, how can I tell when it's a method? Because it's got bow legs. Okay, anytime you have the parentheses, you know it's a method. So the first instance of employee is being used as a type. The second one is being used as a method. It's a particular type of method. It has a special name. It's called the constructor. So the constructor is what's used to build in this case, build an employee. Okay, now one of the things you can do is you can go in here and say, I want to add some data to this thing. So I want to do a set first name, and it's going to be Bob. And then I want to do set last name. I don't know, Jones. Imp1 set department. This one's a little weird. I'm not going to explain exactly what it is, but that's beside the point. He's going to be in engineering. Okay, then I'm going to just keep going. Imp1. I'm going to do set hours. He worked 40 hours. And Imp1 set rate. That's his hourly rate that he gets paid. I'm going to make it 10 so it'll make it easy to figure out the math in our head. So I built an employee and then I went in and told it some specific things. So these are the nouns, okay? These are the fields. So I should, in theory, have a field for each one of these things. Let's go check. Why, yes, I have a field for the first name, the last name, the department, and the hours, and the rate. Right, so these are all fields. I filled in a field. Okay, so I'm going to build me another employee, except sometimes it's just easier to, instead of taking, 6 lines of code to do, I'm going to shorten it up a little bit. I'm going to say employee imp2 is equal to new employee, except this time I'm just going to add some stuff on the command line. I'm going to say Sally Smith, and her department is, she's going to be an admin. Okay, so I've basically taken these 4 lines and combined them into one, and the only thing I have to do left now is to put in the things that associate with her pay. So I would go in here and say imp2 dot set hours, and she's been working pretty hard. She worked 45 hours, and just to make things easy, I'm going to do the set rate, and I want to make it also $10 an hour just so to make the math easy. Okay, now it should be fairly obvious that imp1 and imp2 are not really related in any way. I mean, one of them is Sally and one of them is Bob, and one of them works for engineering, one of them works for the administration section, and one of them gets, okay, I'm going to make Sally make more money. Okay, Sally gets more money than the Bob. All right, so they're not related, okay? Now that I've got these 2 instances, I might want to figure out how much they get paid. That'd be a kind of cool thing. So here we go. I'm going to say, I tell you what, hang on. Let me do double pay1 is equal to imp1. And then there's a method called calcPay. Okay, calcPay. And I'm going to do another one. Okay, is this making sense? And then down here, I'm going to just dump this out to the display so we can see what we're talking about. Display append pay1 equals pay1. Okay. All right, so I've got this guy, and I figured out what his pay is, and then I've got this woman here, and I'm going to figure out what her pay is. Okay, let's run this and see what it does. Whoops, wrong button. Okay, so one got paid $400, one got paid $900. Okay, is that making sense? So these guys are completely separate. Employee 1 and employee 2 are not at all related. And so I did a shortcut here where I've got 3 of the 6 parameters, 5 parameters. 3 of the 5 parameters all on one line. Just a shortcut. Okay, we're coming up on the 15-minute mark.